This video lesson is about how antidiuretic hormone, or ADH, interacts with the nephron. Recall from previous lessons on the structure and function of the nephron that the nephron sits in both the cortex and the medulla of the kidney, the cortex being up here, the medulla being down here, and the medulla has an increasing osmolarity as we go down. So it might be 300 milliosmolar here, all the way down to 1200 milliosmolar here. And although I'm only writing these numbers on the left side, you can imagine them everywhere here surrounding all these parts that descend into the medulla. We've got this increasing osmolarity as we go down. Also remember that pressure filtration happens at the glomerulus, and then there is reabsorption at the proximal convoluted tubule. There is both osmosis and reabsorption of sodium in the loop of Henle, and then by the time we arrive in the distal convoluted tubule, we have a very dilute filtrate. The filtrate in here has an osmolarity of about 100 milliosmolar, which is more dilute than blood, which has an osmolarity of about 300 milliosmolar. As this 100 milliosmolar fluid enters into the collecting duct, which is here, it's entering a region with increasing osmolarity surrounding the collecting duct. Again, remember that this osmolarity of between 300 and 1200 milliosmolar as we go deeper is everywhere around here. And so there is a driving force for water to be reabsorbed from the collecting duct into the capillaries that are not drawn here but surround the collecting duct because of this increasing osmolarity. However, water doesn't move all that easily through the membrane of the cells. It can diffuse through those membranes by osmosis, but it diffuses more easily if there is a facilitated diffusion channel called an aquaporin. And so the presence or absence of aquaporins here is going to dictate whether water moves easily or not. And as we'll see in a moment, that is under hormonal control. So let's look at cases of dehydration and overhydration and walk through what happens, and we'll see that everything comes down to whether these aquaporins exist in this membrane here. So in the case of dehydration, the increased osmolarity of the blood is detected by the hypothalamus. Remember, the hypothalamus is the homeostasis center of the brain. And when the hypothalamus detects an increased osmolarity, meaning more concentrated blood, it triggers the secretion and release of a hormone called antidiuretic hormone by the posterior pituitary gland. In previous lessons, we've talked about the anterior pituitary gland. Now we're talking about the posterior pituitary gland. Just a note that a diuretic is a medication that causes you to urinate more, so antidiuretic means it causes you to urinate less. Antidiuretic hormone is abbreviated ADH, and it is also called vasopressin because of its effects at increasing blood pressure. So ADH is secreted by the posterior pituitary gland, and that triggers the insertion of aquaporins into the collecting duct epithelium, the lining cells of the collecting duct. Aquaporins are channels that allow water to move through the membrane more easily, and so this results in increased reabsorption of water from the filtrate, which would otherwise be leaving the body as urine. It results in increased reabsorption from water, so it doesn't leave the body as urine, but instead is reabsorbed into the blood. That results in the urine being more concentrated because water is not leaving as much in the urine, and because that water is staying in the body, it's being conserved. So ADH results in conservation of water instead of it leaving the body as urine, and the urine is more concentrated. Together with triggering thirst, where the hypothalamus triggers thirst and drinking more, then that will serve to decrease the osmolarity of the blood. It'll dilute the blood back down. Now, in the opposite situation, where the osmolarity of the blood is too low, in other words, you are overhydrated, the hypothalamus again detects that decreased osmolarity of the blood. So that again is detected by the hypothalamus, and that's going to result in less secretion of ADH, or antidiuretic hormone, by the posterior pituitary gland. And as a result, because there's no ADH, there's less ADH, there's fewer or no aquaporins inserted into the collecting duct epithelium. Therefore, it's not as easy for water to pass through that collecting duct epithelium and be reabsorbed from the filtrate into the blood. So there is less reabsorption or decreased reabsorption of water from the filtrate to the blood, and the water is staying in the filtrate, so it is leaving the body as a more dilute urine, and it's not being conserved. The body is losing water, and that loss of water will then concentrate the blood more and serve to increase the osmolarity. So you can see how the hypothalamus is detecting osmolarity of the blood and then sending a message via antidiuretic hormone to the kidneys, determining whether the kidneys reabsorb more water or let more water go out of the body.